Hello, beautiful people. Hope you are fine and doing well. Uh, as the title says, I really want to address uh, a really important topic, which is how we can architect a secure CI/CD pipeline, which is really important, especially in the age of vibe coding and AI currently, and the coding agents and all the pushing codes and vibe coded applications. This is more like a DevSecOps topic, so you need a little bit of DevOps knowledge to know what's going on in this architecture or this design. This will be like the first series of trying to build a whole new CI/CD pipeline with we will try to build the project from zero until we build it in a VBS, a hosted private virtual server, and with one of the repository providers, Azure or GitHub or anything else. So let's start with it and experiment how we can actually design or architect a secure CI/CD pipeline. So the first thing, we all know that we have a developer that is working on a repository and or an IDE actually. And mostly now with the AI slope, or let's say with the AI age, we are writing a lot of code and we are pushing in a huge fast way. And I am sure most of the developers doesn't know let's say 60% of that code being pushed. He trusted the AI agent and he just pushed it immediately. Even he doesn't check what dependencies installed while talking with the AI agent, what code is being pushed. So developer push a code, he tried to open a pull request, and that code lives in a repository, which will be either GitHub or GitLab or Azure DevOps. And then there will be a pipeline. And that pipeline, this is, I would say, the most simplest way to secure your application and your CI/CD pipeline. In that pipeline, you will have several checks, let's say stages, where you first check for secret scanning. Like you will do a basic secret scanning for hard-coded secrets in the application, like .environment variables or any API keys or any references to environment variables or keys that can be leaked. And in case of, this should be actually here. Yeah. So we have several options for the secret scanning, static analysis scanning tools. We have Gitleaks and we have Semgrep. These are the best known, most known in the industry. You can have them as Docker images, or you can have them installed directly on the agent. After your code being scanned and validated from these scanning tools, we know that there are no longer leaked secrets, hard-coded secrets or environment variable. If your application is running on type secret, I would really recommend this step in the PR validation pipeline. Here you would check for any type errors that your app might produce. This will make sure that the app will always be clean with almost zero errors. Yeah. After that, you probably want to check for the vulnerabilities exist in your current dependencies. If your application is running a front end, let's say, I'm mostly talking here about a front end application, but this is also applies for the backend. I am sure 100%. Like in .NET, there is a command that you can check for the vulnerabilities exist in your dependencies. So here we type npm in case of npm package audit or pun audit. This will check for the vulnerabilities exist in your package's current dependencies. And this is very useful because it will show like a list of each, like it will show each package and how vulnerable it is. Like you will have three type of levels of vulnerabilities. It's a critical, medium, or high. And you can then in the pipeline decide what to do when these exist. Like stopping the pipeline, failing the pipeline, or asking the developer to make a change or log it somewhere else. After the PR validation pipeline runs, we made sure like there is no leaked secrets, packages are clean, types are good, no errors in the application. We then build the pipeline. Okay, so we have now the first step was PR validation pipeline. We finished, and after that, your application, let's say the pull request or the merge request is merged. The build pipeline will run, and it will build the Docker image of your application. Now, since we are really interested into making secure CI/CD pipeline, when you build the Docker image of an application, you need to make sure you also follow the best security practices. Now, for example, you try to use a minimal base image of the Docker file, you use multi-stage build, and you run always as a non-root user. This is really important topic, believe me. You also don't need unnecessary, and you need to remove unnecessary packages and caches, and never include secrets. Instead, you mount them into the server or into the image itself, I mean later container. And then you always should have a Docker ignore in your project to ignore things you don't need inside the image actually. And you need to label the metadata image. After you build the image, there is a really necessary step. You need to also use some tool for the image scanning to find vulnerabilities and misconfigurations. Trivy is the most known in the industry, and it really does a good job. And you here, after the scanning, you also have like levels of scanning. You have like a very strong scanning method that you will scan everything, or you have a medium, or you have a low, and also you have results filtered. And upon that result, you also want to decide whether you really want to stop the pipeline and not pushing the image to registry, or continue on that. Let's say that the Trivy scanner didn't find any vulnerabilities and everything is fine. You want now to push the approved image or the clean image to the registry, whether it's gonna be an Azure registry or Docker Hub, or GitHub. Now, after the build pipeline is finished, you definitely need to release the application, or you make a deployment to the application. And the deployment will be done on your server. So how is that done? You have the release pipeline running in Azure DevOps or GitHub or any other platform. That release pipeline will not run until the build pipeline succeeds, okay? And that release pipeline is actually running on your hosted server, or on your server, on your virtual private server, Linux, whatever you've been to. What you're gonna do, you will try to build the image from the Docker registry, basically, and then in this step, you try to inject runtime secrets. You try to inject your secrets from the server into the image. Really avoid doing that in the image itself, or in the pipeline, in the build pipeline, or in the platform you are working on. Always try to mount your application secrets, API keys, whatever, JW keys, during the release pipeline from your own server, or using special services to pull the secrets from. This is what I'm talking about. We inject runtime secrets and unconfig, sorry. So we load the secrets from the server, and we don't bake secrets into the image. This is the whole idea. After that, we simply deploy the container on the server using Docker run or compose. And here we are talking about just Docker images and virtual server. We are not talking about Kubernetes. We don't want to make this complex. Our main focus here is about securing the CI/CD pipeline and detecting any of the secret leaking, packages leaking, vulnerable packages, misconfigurations, that way. Then you can have on your server portainers, and the portainer is actually very useful in the server. It lets you manage the Docker images, the Docker containers, sorry. So how many Docker containers you have in the server? Let's say each container is an application. You have a backend application, you have a front-end application. With portainers, you can have a UI interface instead of dealing with the commands to actually see what images are, what containers are running now, what are their configurations, what are the environment variables set in there, when was the last time the image started, when the last time it was shut down, and basically this is what portainers let you do. So basically that is the most simplest form way how to secure your CI/CD pipeline. This can be very complex, like more complex, but you also don't want to sacrifice the developer time. Like developers don't want to wait for like 15 minutes just to waiting for the secret scanners and everything. But this can even be like has integration test, unit testing, of course, like most of the application have this. But this is, I would say, the most important thing in securing a CI/CD pipeline. There are many tools more, many applications, but this is, let's say, the base architecture that you will need to understand, and the tools that you need. So I would say, if we wrap up this, we can have now 3 steps, okay? So the first step, the developer, or 4 steps. The developer push the code to the repository with his branch. Then he open a pull request or a merge request. He open the pull request with his own branch to the main branch. Then a pipeline will run. This is the first pipeline. This is the PR validation pipeline. And here we do secret scanning, type check, packages scanning. All good. We will merge. It is merged. The build pipeline will run. And in the build pipeline, we will have to build the Docker image that have the best security practices. We will then run a Trivy, and then we will push to Docker registry. Okay, build pipeline finished, release pipeline got triggered on the server. It will pull from the Docker registry, it will inject the secrets, and then we will deploy the application as a container on the server. So that's all from my side, I think. Yeah, this is the simple architecture, not simple, but yeah, how to secure your CI/CD pipeline for most modern way, let's say. Not most modern, but yeah. So I hope this is very useful. This is actually my first YouTube video, so I hope it blows up, and I hope I will continue posting content about DevOps and DevSecOps, and I will promise I will do that. And the next series hopefully will be starting with the application itself, and we try to set up the pipeline on one of the platforms. Thank you all for watching, and I hope you will click the like button and the subscribe and support me. See you.